Hello and welcome to another fascinating episode of the Into the Impossible podcast featuring yours truly, Brian Keating, Chancellor's Distinguished Professor of Physics at the University of California, San Diego, and I bring to you interviews with luminaries, brilliant brains, magnificent minds from a constellation of creative, curious geniuses. And I'm so blessed today to have on the podcast none other than Dame Jocelyn Bell Burnell, who is a hero to millions around the world. She's one of the few people living today that's discovered a new class of astronomical objects. In this case, she discovered pulsars. But these pulsars weren't initially recognized for what they are. They were thought to be little green men, signatures of an alien, extraterrestrial intelligent species, perhaps. In fact, she gave them the initials LGM to denote the fact that these could be possible signatures because they are so periodic, so regular, so repetitive, that they seem to be the byproduct of technology. After all, the best timekeeping devices that we have on Earth are made by human beings with intelligence. So, in this case, she was maybe a little bit dismayed to not find discovery or evidence for an extraterrestrial civilization, but instead the magnetized dead core of a neutron star, magnetized, very highly magnetic star that puts out a pulse of light that we can see throughout the cosmos using telescopes, and like the kind that she built. So she's an experimental astronomer. She actually built the telescope, the radio telescope that was used to detect these objects for the first time. And unlike yours truly, she truly did perhaps lose a Nobel Prize that she deserved. In fact, the Nobel Prize for the discovery of these objects went to her PhD advisor. You'll find out about that and the story behind that as we go on in this interview. But she has no remorse, no regrets. She has said in the past she's glad she didn't win it, the Nobel Prize that is, because now people ask her about it all the time, and they probably wouldn't if she had won it. Now, I think that's maybe just tongue-in-cheek, but she is a delightful human being, and I couldn't be more pleased to present this interview with a really, truly titanic observational astronomer, experimental astronomer, and someone after my own heart who just has such a cheerful, wonderful disposition. We got into many things, including the aspects of philosophy and even metaphysical, existential questions you'll hear at the very end, the so-called final three, thrilling three questions that I ask all my guests who honor me by coming on the podcast. So sit back, enjoy this ride into the impossible with Dame Jocelyn Bell Burnell.
Any sufficiently advanced technology is indistinguishable from magic.
Open the pod bay doors, Hal.
Welcome, everybody, to a very, very special edition of Into the Impossible, featuring a guest who is so renowned and so fascinating that I was dying to wait even 6 months in the making to have a bit of her precious time to spend with us on this day. And actually, we were supposed to record this last week, which would have been December 10th, which is a day that lives in infamy for many scientists as Alfred Nobel's death day. We'll get into that, but it's Dame Jocelyn Bell Burnell. I hope I can call you Dame, or I've never addressed somebody as Dame.
No, don't call me Dame. Jocelyn will do.
Okay, Jocelyn. Well, it's great to be with you. Thank you so much for coming on the show.
Thank you.
And I want to open by addressing the elephant in the room, which has to do with a very simple acronym, LGM. Is it really true that you thought for a moment that the pulsars, the very first astronomical objects discovered via your brain, not just looking at them in the sky, that you thought they were originally little green men, perhaps alien civilization? Was that ever a serious contemplation?
No, it was a tongue-in-cheek nickname that I gave these things. We needed some sort of short name. You can't or talk about, that funny source we keep seeing at 1919+23?
Yeah, indeed. So I was, ruminating, last night as I was looking over your books and your work, and there's a wonderful short documentary about you in the New York Times from earlier this year. I will link to that in the video and text description. But I was thinking you really did do something quite remarkable, perhaps for the first time in human history, which is that you used your brain to discover something, not just your eyes through a telescope, because you made these first discovery of these objects, which we call pulsars to this very day. And I was thinking about all the serendipitous things that had to come about for that to happen, the right wavelength, the right time, the right instrument. And I wonder if you can tell me, are you as fascinated by pulsars now as you were when you discovered them, 54 years ago?
Just to backtrack slightly, I think we don't want to imply that nobody else has a brain.
No, that's true. Although some of my faculty colleagues, no, I'm just kidding.
No, don't go there. I haven't worked on pulsars since about 1968, but of course I have followed the field, and a fascinating field it has turned out to be, with a lot of very interesting stuff. And a lot of quite tough problems as well, understanding how these things radiate.
And what do you think is the most fascinating thing, would you say, about these objects? Is it that they, kind of have this regularity associated with them? Is it that they are the heart of these, corpse-like explosions, massive explosions? Is it their cycle, or is it their very precision, which fascinates people most? What do you think is the most valuable aspect of these strange and wonderful new objects that you discovered?
They're certainly stretching our physics understanding in many ways. First of all, they are very dense objects. There's a solar mass of material in a ball that's 10 kilometers radius. So the density is phenomenal and the physics is staggering. How they radiate has proved to be a pretty tough problem. That's really because we're at the extremes in every dimension you can think of: relativistic, high electric, high magnetic, and so on. So that's interesting, but a tough problem that's, I think, close to being cracked. And we're beginning to link the pulsars with neutron stars in other environments as well.
And looking back, I guess I failed to realize, and it's probably, just my incompetence, but I didn't realize you built the telescope, that you were part of the team that built it, as well as observed with it, as well as analyze the theory of it. Is that era of kind of, science from beginning to end, from conception, obviously, you and your advisor, we'll get into Tony in just a bit, but his kind of coming up with some ideas, some funding, you building it, instantiating these ideas, then you discovering this, then you convincing him that they're real when he thought they were perhaps a spurious systematic signal. Is that era gone? I had a taste of it as a grad student 25 years ago, but I don't see it so much anymore. Should that worry us as a community?
I suspect the era of home-built equipment is passing. We're certainly in astrophysics, we're more and more using big facilities, huge telescopes, getting an allocation of time on them with luck. So it is a different way of doing things. But all instrumentation starts with something fairly simple and built in your home university laboratories. So that's the way many things start.
And when you had to take this strip of chart paper to your advisor, to Tony Hewish, he was skeptical at first. And as I recall a recounting that I heard somewhere on the Internet archives, you almost missed it if you had been looking in the wrong place, perhaps 20 minutes or come 20 minutes later, 20 minutes earlier, perhaps you wouldn't have found it again. But what was that like? I mean, how did you have the intellectual fortitude to convince a much more senior scientist, who's world renowned at that time even? How did you do that? What gave you that confidence? Is that something that you were born with, or is that something by virtue of the fact you had to work so hard to overcome so many barriers you had built up by that time? When did the full Jocelyn Bell Burnell, when did that fully come out?
I think it took a bit of persistence to, first of all, find the things. I had miles of paper chart, literally. I can't remember whether it was 3 miles or 5 miles, but, something like that. And this first signal was occupying about a 1/4 inch. So it's a very tiny part of the full thing. So I think persistence was actually the main quality. Persistent, careful work.
And looking at the kind of breakdown between theory, experiment, observation, analysis, what appealed to you the most? I remember you said once you got, a set of kit of tools, spanners and wire cutters and stuff, and it was very obvious to you that this type of astronomy is very different than other forms of astronomy. What appealed to you the most? Was it being in the field, taking the data, working on the instrument, trying to figure out its peccadillos, or is there something else? The observation, the data, the writing up of publication? What aspect, sub-aspect of all the things that you do and did is most appealing to you?
Well, the data analysis is always exciting, particularly if it's a piece of kit that you yourself have built. You're actually seeing it working. And half of you is sort of checking that it is working okay. And the other half is looking at what it's delivering in terms of science. So that's always a very satisfying and exciting part of any project. It works, and here's some data, folks.
And as we go back in your world line, your history, you came from Northern Ireland and then eventually made your way to Cambridge. And I recall you saying you really battled this notion of the imposter syndrome. And I found it interesting. I recently wrote a book with a foreword written by Barry Barish, who won the 2017 Nobel Prize with Ray Weiss and Kip Thorne. And he wrote the foreword. He was very gracious, but he told me he felt the imposter syndrome after winning the Nobel Prize. In other words, when you win a Nobel Prize, I mean, I wrote a book called Losing the Nobel Prize, but I didn't come as close to losing it as you did. And I want to get into that. And my audience has questions to talk about that as well. But Barry said, when you win a Nobel Prize, you have to sign this little ledger, and the ledger says, yes, I, insert your name, won the Nobel Prize, got my medal, got my share of the prize money. And then Barry is very curious. So he looked back, who won this before? And he looked back and he saw Feynman and Fermi. And then he saw Einstein, and he said, I'm not worthy. I'm just not worthy of being in the same group as Einstein. He felt like a fraud. And I told him on the interview when he did my show, I said, Barry, guess what? Einstein had the imposter syndrome. He thought Isaac Newton was a far superior intellect and changed the course of human history more than any person before or since. And I said, furthermore, Isaac Newton lived in awe of Jesus Christ and felt like he could never approach him. And so do you think this is endemic, to all scientists, or is it more prominent in female scientists or underrepresented minorities? Is the imposter syndrome a generic feature of being a scientist that we just have to learn to cope with, or is it something you can truly overcome?
Imposter syndrome can happen to people in any field of work. I was interviewed by a journalist who said, all journalists suffer imposter syndrome. You're only as good as your last piece. Can you do it again? So I think it's probably quite widespread. It's just not talked about very, very much.
Yes. And I think tools to overcome it is probably to recognize that, right? That it is so widespread and that you're not the first.
Yes.
And I think, especially with I have daughters and I have sons, and I think that there's a tendency for us to look at someone like Einstein, as Barry Barish himself did, and say, I'm not worthy. But at the same time, Einstein wasn't always Einstein. He grew up like anybody else. He didn't come out knowing, the theory of relativity. He had to work on it.
He had rather a checkered student career, hadn't he?
Right, that's right. And I also point out that Einstein was right at least 7 times. He had amazing insights into the nature of reality, but he also has about 7 or 8 huge blunders, not the least of which was about the cosmological constant, which he later, to his credit, recanted his disavowal of. But he also didn't believe things like gravitational waves would exist. And in fact, Barry discovered these along with his colleagues and the whole team. But we never focus on these kind of foibles of great scientists. We just kind of teach it to our students. They came out with the right answer. Here's how it is. Let's rewrite the history books. How would you change the way that we teach people as young people? Is there something we can do to minimize not just the imposter syndrome, but to maximize the product of their quality and their quantity, how many of them there are and how powerful they can contribute to our knowledge of science?
Being a woman, of course, you often get put to teach the first years, the incoming class. partly because the department is keen to show the young women that there are some women in the department, even if there aren't very. So you're not just there as a teacher, you're there as a role model and to some extent an advisor as well, which is okay, once you recognize that. Not sure it's recognized by the rest of the department, but they'll get there one day. Mm-hmm. I very much enjoy explaining things to students. I've done a lot of teaching for a very interesting university in Britain called the Open University, which teaches students at home. They're in jobs and they study at home in the evenings. Mm-hmm. And these days, a lot of it's done over internet. There used to be the lectures, quote lectures, used to be broadcast on television, and there were radio broadcasts and things like that. So that was a very inspiring place to teach because the students were mature adults who somehow had missed out on undergraduate education at the normal time, were more than capable of doing it, although they needed some convincing. It was quite scary, for a 40 or 50-year-old to decide, right, I'm going to do a degree alongside my job. But a number of them do it. They were superb people to teach.
When you think about teaching, also as teaching graduate students, I think a lot of the importance that I see is with regard to being a good role model. And I was talking earlier this year with Brian Schmidt, who won the 2011 Nobel Prize, and he was recounting basically an embarrassing set of events wherein the collaboration that he was involved with and the competition had what he called toxic competition, and that he demonstrated really poor form, amongst scientists for these young people, even though each collaboration made sure to emphasize the work of, he was a postdoc when the work was done. And here he wins a Nobel Prize. His fellow mentee, Adam Rees, wins a Nobel Prize. He was a grad student, and their advisor, Bob Kirsch, didn't. And in contrast to Saul Perlmutter. And so he was saying that they could have done better. They could have really shown this behavior that would be more befitting to model for young people. And they failed to do that. And he was embarrassed of that. And now he's a vice chancellor, basically a president of the Australian National University. I wonder, is there, because Jocelyn, I always find that there's a fine line. Like, you don't want to be too close to your students. I think that can be dangerous. There's all sorts of stories, especially nowadays. You have to keep a professional balance, but sometimes they come to you with personal issues and so forth. How do you strike that balance? They're looking for wisdom. They're looking for a role model. How do you recommend, people like me balance the kind of authority that we have and the responsibility that we have, but also the need that sometimes the student wants to feel, Dennis Sciamma said, the most important thing a student needs is love. Now, obviously it could be very, should be platonic, but how do you balance that kind of, almost familial relationship, but you're also their boss, for advice for faculty now?
Mm-hmm. Interestingly, my first grad student is now my boss. And a very good one he is too. It's great. It's brilliant to have him in the place.
That's wonderful.
Yeah. So in academia, a lot of relationships can be quite complicated. And I think it's important to behave ethically, whoever you're dealing with, whether you think it's a fairly dumb student or whether it's a much respected professor. I think too much of science in the Western world has involved rubbishing somebody else, rubbishing their work. Sorry, you'd probably say trashing.
Yeah, that's right.
And I wouldn't do that, to be honest. But maybe I'm not competitive enough to survive. So,
speaking of competitors that were really kind of like enemies, you grew up, of course, working with, learning from Sir Fred Hoyle. You credited his book, Frontiers of Astronomy, if I'm not mistaken, with inciting this love of astronomy and this curiosity.
That's when I was a schoolgirl.
Yes. And he was a wonderful writer. He was a wonderful scientist, and he was a mentor. I actually had on one of his former students, Jayant Narlikar, who probably left before you were there, but Jayant is still working hard in Pune, India, and he recounted, just a real love affair that he had with Sir Fred Hoyle. Talk about Fred and the combative, bombastic nature that he had, but also this brilliant, gentle side that he had, that he would come to your defense. I've always wanted to ask you, do you think that the support that he showed was purely driven by scientific integrity? In other words, he was one of the most foremost supporters that you should have won the Nobel, and it wasn't fair, at that time. Was that only driven by, support and scientific integrity, or was that partially because of the desire to trash Ryle and maybe Hewish? I don't know. Can you comment on that?
I think you're right. I'm guessing, but I think you're right there. Yeah.
Mm-hmm. What was Hoyle like? Was he at any time kind of a surrogate advisor or confidant, or was it you would right? Because I remember. Yeah, go ahead.
I think I only really saw him twice in my 3 years. He lectured to us grad students, gave us 2 or 3 lectures. I remember he forgot to convert parsecs cubed to centimeters cubed in one of these calculations on the blackboard, which we grad students noticed but didn't tell him. Let him go through, and he says, "Oh, I think I've made a mistake somewhere." And we said, "Yeah, 2 lines up, sir."
But you also
he was in a different institute, so I didn't have very little to do with him.
But he also mentioned in an interview I saw with you, when Tony gave a lecture at Cambridge about your discovery, he was in the audience and immediately grasped the significance of it. What was that like? Was he really this otherworldly? I mean, we know him as sort of an iconoclastic, bombastic figure, as I say, but what was that like to witness? Did you appreciate that at the time, or was that appreciated widely at the time? Because it seems to be quite significant.
Yeah, I was really impressed because Tony's introduction, the account of the discovery and what we'd found, took about 40 minutes. Tony ended up by saying he thought these things were white dwarfs because he fancied a model where there's white dwarfs oscillating and launching shocks. And Fred Hoyle was the first to speak at the end of Tony's talk, and he said in his best Yorkshire accent, "I don't think it's white dwarfs. I think it's supernova remnants." And Fred has hit the right explanation within 40 minutes from cold.
Wow.
Really impressive.
So I never met him, Sir Fred Hoyle, but I did know Giant. I do know Giant and Arlecar. And of course, I work at the institution where Jeff and Margaret Burbage work. And frequently, Fred would come here, and Giant would still come here even after I arrived in the early 2000s. And I wonder, still to this day, Giant believes that the universe didn't have a Big Bang. And I wonder, as a student, I feel like he's so overwhelmed by the brilliance of Fred that he really won't consider any other alternative that Fred could be wrong, even though Fred himself admitted he was wrong on occasion, not very often. But taking aside these things like the Archaeopteryx and all the kind of maybe silly stuff that he indulged in, do you think that he ultimately hurt his case and his position for the record book, so to speak, not so much the Nobel Prize, but just the record books and being rightfully considered one of the, titans of astronomy of the previous, century, at least? Did he hurt it because of his lack of, perceived lack of collegiality per se? And did that have a negative impact on his students? I guess the thing I'm getting at is, what responsibilities do we have as mentors to our students? Like, if we're taking a flight of fancy, is it fair to them that they have to go on this flight of fancy with us?
Right. There's about 3 questions in that, Brian.
Yeah, I'm sorry.
Talking about the grad students and our responsibility towards them. I think some flights of fancy are perfectly in order as long as you make absolutely clear to the student that this is a what if situation. It's good to explore what ifs, and I think it helps stretch the grad student education. But that's only a minor excursion away from whatever the main theme of the grad student project should be, would be my token. But it's absolutely no harm stretching everybody's thinking by occasionally saying, what if? And going on some wonderful ramble.
Yeah. I like to point out, nowadays you're not active on social media. Look, good for you. But I like to do a thought experiment. If you were to take a young Scotsman in the 1860s by the name of James Clerk Maxwell, he had come up with these laws that would later be validated, not really much in his lifetime, but he came up with these laws, and they're actually correct. These four fundamental equations of electromagnetism. But his view of what was, causing light to propagate was that there was an ether, and that embedded in the ether were these gears and vortices and world. And so imagine if Karl Popper had existed back then. This is crazy. This is falsified. We don't see whirls and gears, and so your theory is wrong. And I wonder, if the flights of fancy can be stymied, stifled, suppressed too soon, and that maybe you do need a little bit of that, but with the caveats that you just mentioned. So speaking again about the actual detection, the fact that you built this instrument with collaborators and then saw it. I remember
it was Brian. It was to Tony's design. It was.
Yeah. Sure enough.
And he got the money.
Mm-hmm. And that the original intention was to look for quasars, right? If I'm not mistaken. And that was around the time this catalog came about. And of course, Ryle had assumed that they were, he could use those to provide some evidence for the expanding universe and source counts, et cetera, et cetera. And nowadays we use very different types of radio telescopes to look for these signatures. But at that time, it's often said, Jocelyn, that the discovery by Penzias and Wilson killed the steady state. But I think you're actually a counterproof to that. In other words, in 1965, the Big Bang had been bolstered by the CMB discovery in 1965. You were operating in 1967, so 2 years later. So what was the prevailing attitude? Were you looking for these quasars to give or to study them in their own right, or to maybe provide evidence for the expanding universe? What was your intention, or you and Tony, what were your intentions in conducting the survey?
My intention was to find more quasars, because at that stage we only had about 20. And we knew they were distant. We knew they must be very extreme exotic objects, but 20 is not a good sample. Mm-hmm. That was the main project. And in fact, by the time I'd finished, we had about 200. So that was successful.
Mm-hmm. And then they would, and to get detoured from that, was it instantaneous? I remember you saying once that the most important, piece of evidence was finding the second pulsar, not the first one, because that really convinced you that they were real. And I think that's true. I mean, if you look at LIGO, they really didn't go public until they had two events, black hole mergers. How hard or easy was it to tear yourself away from the intended research goal? Did you worry it would delay your thesis, your graduation? How did it affect you to switch completely serendipitously to a completely different, literally alien field?
Well, it involved the same data. So the data I was collecting served both, which was handy.
And then by the time the significance really sunk in and was accepted around the world, of course, there was a lot of, publicity, and a lot of, in fact, it was sexist and kind of focusing on your measurements and your appearance and so forth and so on. And yet my late great colleague here at UC San Diego, Margaret Burbidge, she rejected famously prizes that were only allowed to go to women. What would you say to Margaret? Like when she rejected the Annie Jump Cannon Award, or because she didn't believe awards should go specifically based on one's gender. Did you? I mean, obviously she's entitled to her opinion, or she was when she was alive. But what do you make of that sentiment? That there are people that say we shouldn't prioritize, gender, and even as you're doing now, which I commend with your breakthrough prize, winnings.
To a woman scientifically proven to be the real deal, Jocelyn Bell Burnell.
That you've turned that towards the IOP and dedicated towards underrepresented minorities, as we call them. Do you feel there's an argument against such things, or do you feel like no, it's necessary to do even at this time?
I think one of the significant factors in the discovery of pulsars was that I was an outsider. I was not a young male. I was not from the affluent southeast of Britain. I had not been to an expensive school. I had not done my first bachelor's degree at Oxford or Cambridge. And so I think that diversity is important. And that's what I would focus on. Try and get a much more diverse scientific workforce.
And to incentivize that, I wonder, nowadays, of course, you can't get a job in America, at least, without, almost an equal amount in the University of California is put on contributions to equity, diversity, inclusivity. That's part of your package, and it's held up alongside with your teaching and your contributions to research. And, my concern sometimes is I don't know anybody who says that they're a sexist. Like they just don't say it. And we have all this training and maybe they are, maybe they're not. But I often feel, to be honest with you, that things are getting better. I mean, we went from Margaret being the only female professor here, and now we've got 4 or 5 in astronomy alone, and it's out of a group of 12 or 13, so it's quite almost exactly equitable, and it needs to get better, but it will. But I feel like we're kind of paying the price for the bad behavior of the generation that you're describing, that you had to contend with. How should we balance that? Those of us who are raised, not to be sexist, and it's sort of in our, we can't conceive of it in the same way that it was commonplace. They used to hoot and holler at you, when you came into class. You've spoken about that. That's completely anathema to everything we do nowadays. So we're kind of riding this exponential tail of maybe past behavior that was really quite sexist. How should we approach that now? Is it necessary to overcorrect in a sense, or will it naturally take care of itself as more and more women get into the workforce and get into the educational force, so to speak?
I think the question you have to ask yourself is, if you didn't have that arrangement, at what rate would women be getting into the workforce? Adequate. My hunch is it needs a bit of a push. It's not a permanent push, it's a temporary push.
Interesting. And I think, nowadays, of course, you're in your retirement, I should say, you've turned, a long time ago away from pulsars. Can you say what things, just as a scientist, are you most interested in? It doesn't have to be in astronomy, but what kinds of things fascinate you, intrigue you, and what advice would you give to a new up and coming, PhD student who's just eager and she just wants to, learn as much as possible? What's the most fascinating thing if you were to start your graduate school career right now? What would you advise such a person?
When I was an undergraduate, my final year advisor was Ron Drever. And he was a very, very stimulating advisor to have. And I made a mental note to watch any field that Ron worked in, because it would probably go places. And not long after that, he got into gravitational radiation. So I've been watching the development of gravitational radiation with interest. Indeed, I used to lecture on it to our grad students when I first went to Oxford about 10 or 15 years ago. They treated it as a bit of a joke. As the years went by, it got more and more serious. And then when gravitational radiation was actually detected, the theoreticians decided they had to teach the course. Interesting developments there.
Yes.
I would say the opening up of a new spectrum is extremely important, and that'll be a good area to watch. Whether you want to work in it or just watch it is another question.
That's right.
And the other thing that's happening in general in astrophysics is the time domain is opening up. So not only do we have gravitational wave events, we have events in all sorts of other objects, flares and things like that, bursts and so on. So there is a huge amount happening within time domain. And I find that very, very exciting.
So now I want to turn to your wonderful monograph, your book, which is called A Quaker Astronomer Reflects, Can a Scientist Be Religious? Well, I think both of you and myself are scientists, and we're both religious. So I want to talk about this because I found your book quite unique, because most scientists will say, well, I'm basically an agnostic and I don't really, believe that there is no God. Maybe there is no God. And I always say to such people, well, and I had Freeman Dyson was the first guest I ever had on this podcast. And he said, I'm an agnostic, but it's a great mystery. And I said, well, Freeman, how do you differentiate yourself from an atheist? Because you're saying you don't practice. So if an alien, intelligent little green man were watching you, Freeman, it would say, you don't go to the same church that Richard Dawkins doesn't go to. So how exactly are you different from an atheist in practice? And I find that almost none of my colleagues, many of whom are, profess to be agnostic. Very few will profess to be theists. And even I myself don't claim I'm a strict theist in the classical sense of, biblical, realism. But you have a unique perspective in that you believe, as I understand it, please correct me if I'm wrong, but you don't believe in, kind of the God of creation of the universe and instilling and instantiating all the laws of nature, but you do believe in a personal God. It's almost the exact opposite of many people that I've encountered. And I wonder if you could elaborate on that. Is that common in Quaker, in the Quaker practice? Is there something unique about you? So first of all, maybe we'll start. I'm sorry for the long-winded question. I do that on time to time. Can you explain Quakerism? I've had on at least one Quaker, I believe Matt Stanley, and we talked about Eddington. But can you say a little bit about Quaker for those that aren't familiar? Is it just like ordinary doctrinated Catholic Christianity, et cetera?
There's a huge spectrum of Quakerism in the United States. So there isn't a simple answer to this. The kind of Quakerism I'm involved with does not have priests or bishops or archbishops. Reckons that everyone can from time to time be called to do that kind of ministry. But in the United States, as European people migrated westward, the Quakers gradually evolved a bit, and you'll now find there are Quaker churches that have a service on a Sunday that is led by somebody. That wouldn't be the case in Europe, for instance. So there's now a huge spectrum of Quakerism in the world, some with pastors and leaders and some deliberately without.
And you talk in that book about your working hypothesis of a living, loving God who works through people and calls us to hope and ethical action. So what is the practice like in practice? Is it for you? Is it a daily, we'll get to your studies of the Mishnah. I'm fascinated by as a Jew, but what is it like on a daily basis? Is for you, just personally, is there prayer? Is there scripture? Is there meditation? How do you instantiate it?
The Quaker worship is sitting in, the Quaker worship that I'm used to is sitting in silence, cogitating, listening, feeling, and sometimes you get useful thoughts which you'll share with the other people sitting with you. And I will do that 2 or 3 times a week, typically. A lot of it on Zoom at the moment, which is not so easy, but it's sitting with people you pick up better what's going on than on Zoom. You miss a lot of the signals when you're on Zoom.
Absolutely.
Better than nothing.
Yeah. And I wonder if that ties into, one of the biggest challenges to a personal God for many people is this issue of theodicy, of why do, bad things happen to good people? Why do good things happen to bad people? By the way, which is more annoying to you, when something good happens to an enemy or when something bad happens to a friend?
I don't have an opinion on that.
Okay, fair enough. So the problem of theodicy is an old one. How can a personal, just, loving God, as you ascribe to, how can that be compatible with the suffering, the natural disasters, the viruses, the earthquakes, and so forth. How do you reconcile that? Or is that something, that will always be an ongoing part of your working hypothesis? And in other words, Jocelyn, how could you falsify your working hypothesis in a sense?
Look, that's about 4 questions in one.
Sorry, I told you. I should have warned you beforehand. I am long-winded. Sorry. So theodicy first, and then can you falsify your working hypothesis? Let's do that.
No, I can't falsify the working hypothesis, and don't try to. Quick answer to that. No, sorry, I've lost the thread where you started.
Well, I guess, the notion of the personal God and incompatibility with bad and happening to good people, et cetera, is that something that could be a permanent barrier that you choose to overlook, or is it something that is an ongoing struggle, and that we just have to cope with?
You've made an assumption. God's there to smooth the path for you, and I don't think that assumption's right.
So what does the personal God do? I mean, he didn't create the universe, and as I understand it, in your conception, I should say, so what does he or it do?
Help you along the route by offering guidance is too tangible. But if you focus on God with luck, your decisions will be kind to other humans as well.
So yes, it's the process more than just the entity. In Judaism, as you know, we believe in the twofold manifestation of God, that God created the universe in Genesis 1:1, and then led us out of Egypt in Exodus 1:1. In other words, that there's a personal nature, that God did intervene in the events of human history. And as a scientist, I will often get asked, how can a serious scientist believe in the Bible? So I'm going to ask you, well, you're not as Bible focused maybe as I am, but maybe you are, I don't know. How do you reconcile that? I have some answers, but my audience wants to hear what you would say.
I don't have an issue there. Don't have a problem.
So you mentioned at the end of the book that you enjoy leading and participating in Bible study, which is loosely based on the Jewish Midrash. I found that fascinating. How did an Irish woman who's a Quaker, how did she come to even know what the Midrash is? So first, explain your understanding of the Mishnah, and then what does it do for you, or what do you do for it, so to speak?
This I was introduced to at a big Quaker meeting in the US. I can't remember now which one it was, where in a study group, it was suggested that we read together a passage of the Bible. We each took the role of one of the characters and then wrote up our diary, or wrote to our mother describing what had happened in that story from the perspective of the character we had assumed. And I found that extremely useful, because it rounded out a lot of the Bible story. And so something that I found very, very useful, and grateful to have been introduced to it.
Yeah. So for those that may not be so aware, so ecumenical as Jocelyn, this is a set of rabbinical collection of stories that kind of fill in the gaps. I mean, some of them are pretty famous. There's a notion that even my kids will learn about, that Abraham was put into a fiery furnace, and that was one of his tests. And yet it's never mentioned in the Torah and the Old Testament. And that comes from the Midrash, and it kind of explicates these missing links, so to speak, between in the story. And then the Talmud itself is really a collection of case law and interpretation of these sentences, like, thou shalt not murder. Like, what does that mean? Or an eye for an eye. That's the perfect one. An eye for an eye, could kill somebody, but it's not what it means. And so there has to be some interpretation, or kosher and stuff like that. So I found it very, very interesting. And that you brought this to a religious audience. I mean, this is what it was for, and the Quakers. And as I said earlier, Eddington is perhaps one of the most famous scientists who was Quaker, and that is believed to play some role in his life as a scientist. So I love the fact that you basically say that you don't blame God, for kind of the workings and orchestration of the universe, but you also don't give God credit. And oftentimes we'll hear that from Einstein, like, I believe in the beauty of God as evidenced by the organization of the, but you don't feel the same way as Einstein, right? Mm. So, and the other parts of that book that are so delightful are really the description of the modern astronomer's understanding of the universe and how the universe is depicted, not necessarily as an organization. Did you find people were receptive to it? Was it did it cause tension? I imagine there might be people that don't believe as you do, even within the Quaker faith, right? So what was the reaction to this book?
It's the text of a lecture that I gave. It wasn't originally a book. Mm-hmm. I gave it at a gathering in Australia to Australian Quakers, and it seemed to go down quite well. Had a number of interesting conversations following the talk. I do remember it being incredibly hot. We were in Canberra, and I forget what the temperature was, but it was very, very hot. And there were fires further inland. It was Australian summer. It was. Mm-hmm. So I think people took more than a polite interest in it, but there were other things going on at that conference, around that conference.
Interesting. Okay, so now we have questions from my audience, and apologies if you don't want to answer any of them, please feel free. But Henry Selden says he's disgusted after reading your history about you not getting the proper credit for the work you did. He wants this corrected and procedures put in place to ensure this disgrace never happens again. His question: has what we've learned about radio pulsars since you discovered them changed your perception of what they are? Do we know for sure what they are and how they form? Thank you for all that you've done to promote our learning.
I think we've got pretty good understanding of what pulsars are. Where we are still needing more work is how they produce these beams of radio waves that then swing around the sky. So we see a pulse each time the beam swings past us. We got this bit right, but what the beam is, there's still work going on. It's incredibly extreme physics because there's large magnetic fields, large electric fields, rapid rates of rotation, and in the star itself, extremely high densities. It's hitting the extreme in every dimension you can imagine. So it's tough physics.
Indeed, it is. Next audience member says his name is Timbo. Do you mind if we call them Pulsars in your honor? Should we change their name from Pulsar to Pulsar?
Far too late to do that.
Okay, and then he says, I've seen one recent commentary from a documentary that he saw. Your role shines brighter in the way that she handled the snub by the supervisor in the Nobel Committee. Around respect for Fred Hoyle likewise increased when I heard this objection. Okay, so we basically covered those already. Okay, Kenny Wayne Beek asks you, I would like her to expand upon her quote. I believe it would demean Nobel Prizes if they were awarded to research students, except in very exceptional cases, and I do not believe this is one of them. Do you still stand by that? Is his question.
Largely, yes, but I had to handle a lot of very tricky politics around about the time of the Nobel Prize. So yeah, I think that's all I'll say.
Mm-hmm. Okay, fair enough. And then, so he asks, did you initially think the radio signals were observed were extraterrestrial civilization? We talked about that, but let me ask you a different question. In the US, at least, there's been a resurgence in interest in what are called UAPs, UFOs. First question, do you believe that there is that there's any evidence for extraterrestrial life of any kind, technological or not, in our universe, or let's just say in our galaxy?
I don't think we've seen any sign of life yet that would convince me, no.
Would you say that it's therefore not terribly wise to make statements that there has to be life out there because the universe is so big? And in other words, I guess a version of the Fermi paradox. Do you believe there is life, or do you believe the question, do you believe, is insufficient or inaccurate?
The universe is very, very, very large. I think it would be a bit stupid to say there is no other life in the universe. There will be no other life. There has been no other life. It is so very, very large. I think being that dogmatic is unwise.
And then the next question is, what is one cosmic mystery you'd like to see demystified? Dark energy, dark matter, inflation, or something else, all of which you talk about in Quaker Scientist.
I haven't got a particular favorite. I'm looking forward to the Vera Rubin telescope coming online, because I think there's a lot more in the time domain, things that vary, that we have yet to find. And I think that's probably going to deliver it to us in bucketfuls. It's going to be a fantastic telescope. So what I think will be the next interesting area. A complication is that the analysis will have to be done by computers. Computers have to be programmed by people who think they know what they're looking for. So, you know, if our computers had been programmed, if we had had computers to program, would pulsars have been discovered? I wonder.
Very good. Okay, there are other questions that have to do with the folks that don't believe pulsars really exist. And I guess that might be a symptom of, you know, there are people that believe that the earth is flat, that birds aren't real, and all sorts of other. How do you handle skeptics, like pure skeptics? Pulsars don't exist. How do you convince, as Rabbi Hillel said, how do you convince someone while standing on one foot?
I'm not sure it's worth trying, to be honest.
Okay, fair enough. And I will not belabor the point.
Live and let live, as they say.
Well, we have now reached the point where we'd like to discuss the existential questions of life, including what I call my thrilling 3 final questions that have to do with telling your full story in the context, the challenges, the action, and the epiphanies that you've gone through in your legendary career, and you continue to do, and you continue to inspire. And I want to connect them to the questions that I ask all of my guests. If you are willing to, Dame Jocelyn Bell Burnell, would you be willing to go into the impossible and answer these final 3 questions?
I don't know what they are, Brian, so let's see how we get on.
All right, we'll delete them if you don't like. Okay, the first one has to do with your ethical will, not your material will. In Judaism, we have a desire that people should live to be the age that Moses was when he died, 120 years old, and like Moses, give over a will of ethical content. And this is sort of originally done by the patriarchs in the Bible, but nowadays they're for everybody, including you know, people of all different stripes, professions, etc. So I want to ask you, what sort of wisdom would you bequeath? You've already been so generous and gracious and bequeathing tons of literal financial wealth to future generations. But what wisdom or advice would you give to future generations when you leave this mortal coil, as Shakespeare said, at the age of 120?
I hope I don't last that long.
Well, we hope you're right. We hope you will.
I would say, try not to waste your life. Make good use of the time given you. Be courageous. You can be overcautious. Be generous, be kind, be thoughtful.
Very good. Okay, that wasn't so bad. The next one has to do with Sir Arthur C. Clarke's thrilling film, 2001: A Space Odyssey. I don't know if you've seen it or not, but the movie version of it, it depicts some hominids in Africa, and they come upon this monolith, this huge structure, and they don't know what to do with it, and they hit it with a bone, and and then later it appears in space, and it's on the moon, and it seems to be sort of a time capsule or some sort of advice or billboard placed by a civilization millions or billions of years ago, but meant to be discovered when human beings can appreciate it and unlock it. And maybe we haven't gotten to that point yet, I think, is what the film depicts. And it reminds me of Richard Feynman, who said, you know, if you had to recreate civilization after some cataclysm, what piece of knowledge or would you put on a time capsule that really bespeaks to what human beings have accomplished? And he, of course, talked about the atomic hypothesis. What would you put on a time capsule now, not 100 years from now, but 1 billion years from now? What would you say most signifies the scientific heights that humanity as a whole has achieved as of this day?
Gosh, I've never thought about that one. I don't think I can answer that. I'd need, to go away and ponder it.
Okay, maybe in part 2 someday, if you'll grace me again. The last question also has to do with Sir Arthur C. Clarke. And as you know, he had many laws, one of which I open every podcast with, including this one, him saying in his own voice, any sufficiently advanced technology is indistinguishable from magic. He also said things like, for every expert, there's an equal and opposite expert. And then the third thing he did was give me the name of this podcast, because he said the only way of discovering the limits of the possible is to venture a little way past them into the impossible. And I like to ask that question of you by saying, what kind of mysterious thing perplexed you as a 20-year-old or maybe a 30-year-old as a young person? And what epiphany did you have that gave you the courage to go into the impossible and push the boundaries and the limits of what seemed to be impossible at first? Basically, advice to your former self.
I think I've been pushing boundaries all my life. It's been hard being a female who wants to have a career, a female of my age who wants to have a career. Let alone a career in science, let alone a career in physics. So I actually think I've done a lot of pushing of boundaries. The only thing I would want to add is you need to be a bit subtle in how you push the boundaries. Mm. Go straight at them with a battering ram. I don't know if that answers your question, but
no, I think it does. I think it does. And the fact that you are so willing to be vulnerable and to talk about your experiences with honesty and courage, it really has served as an inspiration. I can't believe I'm talking to you, and it's been such a dream and such a delight to learn from you and to learn how to teach from you. In a certain sense, the graciousness that you have, the brilliance that you have, and the dogged determination of an experimentalist who saw things through from the first wire snips that she ever got all the way up through a discovery for all time. And I just want to thank you for spending so much of your valuable time with me and my audience. And I can't wait to see where you go next. And hopefully we'll get to chat again in person maybe someday.
Thank you very much, Brian. Thank you.
It was a delight.
Any sufficiently advanced technology is indistinguishable from magic.